If anyone wants to say hi to the whites or Maylee.
Hi, Maylee. Hi, Jessica. Hi, Erica. And anyone else listening.
This is so I didn't forget.
This is like a podcast.
It is like a podcast.
We need like a podcast.
Happy Friday!
Just say good morning to all.
Good morning.
Wait, can they actually hear us?
I mean, not live. This isn't live.
But I'm saying like.
Oh, they can hear you.
Guys, we need a podcast.
So if we say stupid things or I tell you my life story, like it's just gonna get posted.
We all have to like
Correct.
around.
Why does this sound both before? I feel like I should be signing a waiver right now.
You're notified by the blinking light on the board.
That's not no. That is not a clear
I'm
notification.
gonna pause this thing. I couldn't because like I can't even say it. So we all have to microphone around to say.
You don't have to pass it around. They can hear you.
Do some ASMR.
Hi guys, today I'm gonna be eating some aloe plants.
So yesterday we did inductive reasoning where we looked at the pattern. And
Is that Ben?
Shane and Ben have arrived.
Benjamin and Shane.
We're podcasting for Maylee and Erica
Do you
and
know what
Jessica.
voted you for, bro?
And Jenna. Sorry, Jenna, we forgot.
Oh,
Hi,
hi,
Jenna. Hey, Jenna.
Okay, exactly.
Hey Jenna, do you work today?
This will be even funnier next year whenever I keep the same recording up. And they're like, who's Jenna? Who's Erica? Okay, so yesterday we did inductive reasoning, and
Wait, I think I need to know to
they are over in the while you're out box.
Wow, this is gonna be one long video.
So yesterday we observed the pattern. Today we're actually going to prove it true for all cases. Remember how my conjecture was wrong yesterday about my class having all girls in it? So today we're actually going to have something that is provable. And so this is the process of proving a scientific conclusion from one or more general statements. You did this in geometry with your two-column proofs. Remember those? Statement, reason? Well, don't worry, we're not doing this. But you proved something from the start to the finish so that it worked all the time for that. So you're kind of creating like a rule of sorts. So yesterday we had conjectures, which were like educated guesses based on an observation. Today we'll have theorems, which will be a conclusion that is actually proved to be true using deductive reasoning. And I don't really like these word examples, but we'll do one of them. But all your homework is like math examples of deductive reasoning. Not. And most of you probably don't know the rules of Scrabble, so that will make the first one even harder. Scrabble? That's what the first example is about. Deductive reasoning allows us to draw specific conclusions from one or more general.
To draw a specific conclusions.
Hey, this is an English class. Keep yourself.
Yeah, I'm not an English teacher. By any means. Alright, so we'll do this one and not the next one because this one has less writing involved. Although the next one will probably be more logical. First of all, there are no 7 a.m. classes in college, they're 8 a.m. But don't sign up for them unless you have to. Because you won't want to get up.
Even now, I don't want to get
Exactly. Okay. So, everyday situation. One player says to another in a Scrabble game, you have to remove those 5 letters. You can't use Texas as a word. So, first of all, you need to know the rules of Scrabble, which are that you can't use any proper names. So, all proper names are prohibited in Scrabble. Again, would not put this on a test. I don't expect you to know the rules of Scrabble. This is just an example using logic and words and scenarios. You don't know what Scrabble is?
I've never.
It's where it's words with friends, but like on a board.
That's right. Okay, I know where. Oh God.
Before apps existed.
Somebody add.
So based on that, if you know this and your friend tells you this, you can conclude then that Texas is a proper name. Therefore, Texas is prohibited from Scrabble. So you're basically taking a scenario, a rule, applying the rule to the scenario, and then proving that can't be used. But again, the majority of our problems are not word or situation based. They're going to be math based. You might want a calculator if you don't like doing mental math, but the numbers aren't too big today, so it should be okay. We're going to skip that next one about the college classes and get into the math. And then we are going to do one of the homework questions together, so you'll have even one less homework question. Just because it's a little different than the ones in the notes, and I want to make sure we go over it. All right, so we're skipping that. All right, so what we're going to be doing on the back is deductive reasoning proofs. So it says, consider the following procedure. Select a number, multiply the number by 6, add 8 to the product. Divide the sum by 2, subtract 4 from the quotient. So you're taking a number and you're performing all these things to it, and you're getting an answer. Now, what we're going to do is we're going to do this procedure for at least 4 different numbers. And I've picked the numbers I'm going to do at the board, but you could literally pick 1, 2, 3, 4 if you wanted to. And then we are going to write a conjecture. Now remember, conjecture was from yesterday. Conjecture could be right or wrong. Okay, but we're going to write a conjecture that relates the starting number to the ending number. And then we're going to prove it true using a variable, n or x. Okay? So we're taking this number, and we're going to, in this column, I'm just going to write down all of the operations. So we're going to multiply the number by 6. We're going to add 8. We're going to divide by 2. And then we're going to subtract 4. And this chart's just kind of like to help you keep organized as you go through the process. So take the number 3. 3 times 6 is 18. 18 plus 8 gets me 26. In case anyone's not following, taking this number, doing this, writing it here. This number, doing this, writing it here. Okay, 26 divided by 2 is 13. And then 13 minus 4 gets me 9. See if you guys can complete the next 3 columns. And then what we're looking for is a relationship between the starting number and the outcome. So right now it could either be 3 times 3 gets me 9 or 3 plus 6 gets me 9. So you want to complete all 4 columns and see if we can use inductive reasoning to make a conjecture to relate those values. Who could tell me what they got when they performed the operations with the number 5? Kara?
For all of them?
Just for 5.
I think 15.
And who can tell me what they got for 8? When they performed the operations. Just for the final column. Shaylin, what'd you get? 24. And then 10 we got? 30. Alright, so we notice that, what Brandon just said, they're multiplying by 3. 5 times 3, 8 times 3, 10 times 3. So the conjecture is that we're going to multiply the original number by 3 instead of performing all of those operations. Alright, now some students are like, well, I did all that work, like that's the important part, but really, this is not the important part. This is just helping you come up with what the conjecture is so that you can use deductive reasoning. All of this is just what we did yesterday. This is inductive. We're observing a pattern based on numbers. Now we're going to do deductive reasoning, which is proving it with a variable. So n or x, and it helps sometimes if you add like an extra column at the end with an n at the top, n being any number you want. We are going to perform all of these operations with the variable n. So we're going to take n, multiply it by 6. We get 6n. We're going to then add 8 to that. To get 6n plus 8. Then we're going to divide that whole sum by 2. So put all divided by 2. And then the n we're going to subtract 4. And you really don't have to do all these columns if you just want to do it in your head and then write that part at the end. Now the part of deductive reasoning, the proof, what you're going to do is you're going to take what we've gotten here, 6n plus 8 divided by 2 minus 4, and you're going to set it equal to the conjecture. All right, so our conjecture was what? That it's multiplying the original number by 3. So if we're letting the original number be n, the conjecture for this would be 3n. 3 times the original number, which is now our variable n. All you have to do at that point is simplify this left-hand side and prove that 3n equals 3n. So, just cleaning it up a little bit using some simplifying strategies, we're going to divide each of these numbers by 2 to get 3n plus 4 minus 4. And plus 4 and minus 4 gets us back to 0, therefore 3n equals 3. Give yourself a little check. So that's this right here is the deductive reasoning important part of today's lesson. Proving this for any number. That performing all these operations is the same thing as just taking 3 times the original number. Okay? So you're proving your conjecture to be true. All right, to closure, I didn't give you guys a table, so you can just sketch a little one. And I picked the same numbers, but again, on your homework, you can pick any numbers that you want. If you want to have the same answers as me on the board, pick 3, 5, 8, and 10. But it doesn't matter, just to help you find your conjecture. So we're going to take a number, we're going to multiply it by 4. We're going to add 6, divide by 2, and subtract 3. So let's do the first one. 3 times 4 gets me 12. 12 plus 6 gets me 18. 18 divided by 2 gets me 9. And then 9 minus 3 gets me 6. You do need to do at least 3 columns before you make your conjecture. You don't have to do all 4 if you can observe the pattern. But I'd like at least 3, just to prove that indeed it does work for more than 2. So again, at this point, after you've done the 8, if you can notice the pattern, you don't have to do the 10. What is the conjecture that we noticed? And remember, it's not the relationship between the n numbers. That's what some of you will get confused on. You'll be like, oh, what's the relationship from 6? Oh, there goes my flip chart. What conjecture do we notice from the original number to the outcome? Or doing what to you get from 3 to 6, 5 to 10, 8 to 16, 10 to 20. They are, Julie? Multiplying by 2. So that's our conjecture. The conjecture is 2 times any number, which again we'll use a variable to represent that, so it'll be 2 times n. At least I always have this on video showing how things don't work in my room. Alright, so just real quick, let me fill this out. 6, 10, 16, 20. Again, so you're looking from the original number to the outcome. and noticing that the multiplying the original number by 2. So to make that an algebra expression, we just put 2 times n, any number. So now we're going to take and perform all the operations with n. So this was times 4 plus 6 divided by 2 and minus 3. We're going to take the n and do all of those things. So n times 4 is 4n. 4n plus 6. Divide all that by 2. Subtract 3 at the end. Okay, so all I've done is taken the variable n, performed all of these operations to get this expression, and then the important part is to now set that equal to our conjecture. Which our conjecture is that it's always going to equal 2n. And then all we have to do is simplify and prove that 2n equals 2n. So simplifying our division here. Plus 3 minus 3 is 0. So we've proven that it works for any number. You can put a fraction, a decimal, positive, negative, any number you pick, it will get the same outcome. All right, now I want to do one from the homework. 36 we're going to do, so you'll have one less of these to do on your own. So if you want to grab notebook paper if you don't have any, go ahead and grab a piece off the side. Okay, so for all of the homework, part A is to do the table, part B is then to do the proof. Okay? So for 36, we have a number. We're taking that number times 3. Then we're adding 6. Then we're dividing by 3. And then in the directions it'll say subtract the original number. So in your chart, you can just put minus orig. Because for each number, that's going to be different. Depending on what number you plug in, to know what number you're subtracting at the end. And again, the numbers I picked were 3, 5, 8, and 10. I don't know why. Usually when you get to 8, you can observe the pattern, and then you don't have to do the 10. But if not, and if you don't notice a pattern, then check your math, because you may have done calculations wrong. That can happen. So let's complete our operation. So 3 times 3 gets me 9. 9 plus 6 gets me 15. 15 divided by 3 is 5. And then it's 5 minus the original number, which was the original number 3. And we'll get 2. Okay, so the relationship from 3 to 2, I'm not seeing it, so let's just keep going. 5 times 3, 15. 15 plus 6, 21. 21 divided by 3, 7. And then it's 7 minus the original number, which was 5. We get 2 again. Weird. Complete at least another column and see if we get 2 for 8 and for 10. Do we get 2 for all of them? Isn't that weird? So our conjecture is that it's always going to be 2. So for part B, they ask you to write your conjecture. Your conjecture is not 2n. 2n would be 2 times the original number. We're not saying it's 2 times 3 or 2 times 5. We're just saying it's 2, period. End of story. Okay, now let's do our proof. So let's take the variable n, and let's do all of these things to it. All right, so n times 3 will get me 3n. Add 6 to that. Divide the whole thing by 3. Now, what do I do when it says subtract the original number? Kira?
Put n into that?
Yeah, the original number was n in this instance, so we're going to subtract n. Now, take this whole expression and set it equal to our conjecture. Which our conjecture, we said, is that it's always going to be 2. Not 2n, but just 2 every single time. Now we just have to simplify on the left-hand side. 3n divided by 3 is 1n. 6 divided by 3 is 2. And you'll notice 1n minus 1n is 0n. So we're left with the fact that 2 is equal to 2. So we've proven that no matter what number you plug into this crazy series of operations, you're always going to get 2 out no matter what happens. Okay, so that was the one I wanted to do just because in the homework some of them have that subtract the original and make sure you guys understood. But make sure you have at least 3 numbers that you've plugged in until you figure out your pattern for the rest of the month. And then our homework is just 35 through 38, 49. 49, 51, and 52 are not the charts. They're just I think vocabulary or multiple choice questions. So you now only have 3 more of those table questions to complete.